Okay, so hello everyone, this is Akshay here. Today's question name is count pairs whose sum is less than target. We've been given an array and integer target. We need to find the number of pairs in the array whose sum is strictly less than the target. So similar question we have done in the past, or let's say 2 to 3 days ago, where we need to find the number of pairs whose sum is exactly equals to target, right? And it was not actually the yeah, it was not actually pair, but it was actually equals to the sub-array. So brute force technique always remains the same for such questions that whatever it says, count all triplets, count all sub-arrays, count all pairs. We brutally made all the pairs using a nested for loop. If there's a triplet, then you will need three loops. If it's a sub-arrays, you need two loop. And there's again a pair, then you need to use two for loops, right? So I'm not gonna code that solution live. Let me just code that solution and then get back to you. Okay, so this is the same code which I copied from our previous question just to save time. And let's change the thing. So we have sum, we have answer, and definitely this will give us the what to say, the pair thing. So since if it is I equals to 0, then we need to start for another pair. You need to start from I plus 1, right? And sum we again initialize for a current pair as sum equals to 0, and then sum is nothing but sum equals to array of I plus array of j, right? And what is the condition that we need to check? If sum is less than k, is less than your target, then do an answer plus plus and just compile and run for the solution. So what with the time and space? O of n square as time and O of 1 as space. Great, output matches and you can submit the solution as well, but I think you'll get it really because n square means you're using 10 power 5 whole square. This is important. And to submit your code for a successful submission, you should code it in less than 10 power 8. So clearly you can see some of the test cases has the DTLE. Okay, okay, only one, but great, yeah. Uh, let's just come back to our OneNote and visualize that how we can solve this question further. So before moving ahead here, right? Uh, you may be wondering ki if the question comes to you, what is the thinking approach? Like भैया आप तो solve question करके भी दे रहे हो and शायद मैंने भी कर लिया था, I was able to do it. But what should be the correct way to solve a question? What should be a roadmap, a path to think or approach a question? ठीक है? So again, going off the topic to this question, to the today's video, I would say you must practice some prerequisite bunch of questions. I'll just say prerequisite questions, right? Which have all the algorithms, the questions, the standard question that is Dutch national flag. We have cadence, and then the standard algorithms, BFS, DFS, Bellman-Ford, Prims, Dijkstra, Kosa-Rajvi, each and everything, right? This sums up to what I find. This sums up to 360 questions, right? This 360 question you must revise each and every day, depending on how are you versatile. अगर आपको ज़रूरत पड़ता है कि 5 दिन में मैं चीज़ें भूल जाऊंगा ये एल्गोरिदम, देन यू नीड टू रिवाइज 5 days इंटरवल. अगर आपको लगता है आप एक दिन में भूल जाओगे तो यू नीड टू रिवाइज इट. अब भूलना इज़ अ वेरी नेचुरल टेंडेंसी. आप ये मत समझो कि मैं क्वेश्चन आया है तो मैं खुद से सॉल्व कर लूंगा, एकदम इंट्यूशन सब कुछ मिल जाएगी. इंट्यूशन यू विल गेट द इंट्यूशन सॉल्व द क्वेश्चन ओनली when you have solved this prerequisite bunch of question, right? There is very famous question, right? Count set bits. ठीक है, फ्रॉम 1 to n. आई हैव मेड दिस वीडियो ऑन दिस एंड आए दिन मेरे को इस पे कमेंट आते रहते हैं कि भैया आपने इंट्यूशन से समझाया नहीं है. तो इंट्यूशन यही है यार कि प्रैक्टिस दिस क्वेश्चन फर्स्ट, द 360 क्वेश्चन फर्स्ट, राइट? Once you have the prerequisite and then you come to this question, you will directly jump to this question and you will have your negative feedbacks, negative everything, right? Negative aura, negative energy, demotivation, everything. And that is the reason by the end of this year I was also trying to make up this list. So by the end of the last year, we uploaded one video, 20 minutes. So it is what it takes, and we have shared our DSA 360 sheet, right? So ये standard question आप जरूर से practice करें and then only jump to the specific questions or the variations of it. ठीक है, coming back to this question again. Where was this question? This one, right? So intuition for this question again. The standard question which was part of this sheet was a pair sum problem, right? Pair sum problem, or let's say in the technique you can say 2 pointers, right? अब to make this technique work, 2 pointers, right? आप क्या करते हो? If I ask you, you have some bunch of elements, let's say this one, right? 5, 2, 3, 4, and 1. You declare 2 pointers, low and high, at the extreme ends of the array, and then you decide based on some logic, you decide to move L plus plus and then high minus minus, right? Assuming that L is covering the elements from left to low to high, and high is considering the elements from high to low in this direction, right? Now, to make this technique work, you are using some logic and you're moving inwards from both of the ends. So logic भी तभी work करेगा when you have some pattern in your array, right? So what is the pattern? So for any two pointers thing to work, you need a sorted array, right? You need a sorted array. So that first we have an existing pattern in this particular array, and then we can, based on our logic or what the question has been asking, we can decide where to move forward. So let us sort this array first. So 1, 2, 2, and what else? 3, 4, and 5. Let us name the indexes as well. So this is the index 0, 1, 2, 3, 4, and 5, right? Let us declare the high pointers and low pointers. So this is our low, this is our high, right? You need to you need to get the pair sum, right? So this is one of the pair, right? So array of let me write it as array of low plus array of high, right? Calculate the sum. What is the sum? It is 6, right? And my target is 5, right? Now what you need to do, now we will decide which pointers to move ahead and back and forth. My target is 5, but my current sum is 6. That means if I have to match my current sum to my target, I need to decrease my sum. Can I say I need to decrease my sum? If when when my sum is greater than target, or let's say k. How I'm gonna decrease the sum? We already made sure that there should be one existing pattern in the array by sorting it, right? My left is here, my high. If I move left to left plus plus, then I'd be increasing my elements. That will, in totality, will increase my current sum. So that I'm not going to do that. So in the high end, if I move h minus minus, then you can see the elements are decreasing because we had ensured that the array was in ascending sorted order. So that means if sum is greater than k, you need to do a high minus minus, right? Because we need to decrease the sum to make it equal to the target. So again, we will decrease it h minus minus, and now my again the current sum is 5, right? Which is equals to my target, right? So this is the case where sum is equals to k. So can you see that if this L and if this H matches to be equals to target, this pair, then can you say for all the elements inside this range will also be less than k, right? Equals to k, find another less than k. Actually, we have to find the less than k, right? So equals to k also will also skip the part, right? I confused it because pair sum is always equated to equals to k, right? So in this case, it is again the sum is greater than our target, right? It is still not less than target. Can you say that? Yeah. So we still need to decrease our sum. So we'll again do a high minus minus, right? We'll again do a high minus minus. Yes. Hmm. Doing high minus minus, I'm getting to this point. Now my current sum is again, this would be my current high now. So my current sum is 3 plus 1, 4. Okay, it is 4. Now can I say that if this low and this high, which lows and highs I'm talking about this one. This low and this high. If it is less than k, then can I say for all the elements between in this range will also be less than k? Because eventually these elements would be less than my this high variable or high pointer variable, right? Because it is sort of in ascending order. So can I say that 1 2, and like I can make this pair first, I can make one with this pair, I can pair one with this one element, and I can pair one with this element, right? So total count comes out to be 3, right? And how do we make the count irrespective of how do we represent the count in terms of our high and low pointers? We can say just high minus low. That is high is pointing to 3 index, and 3 minus the low is pointing to 0 index. So 3 minus 0 is 3, and we are getting 3 count as well, right? So if sum is less than k, I'm going to include my answer plus equals to high minus low, right? And there's an else case. So there's one else case as well. So let us see for that as well. Now the sum has been less than k, and we calculated the answers, right? Now in which direction I should move? Shall I decrease my high pointer? No, because that was the case for sum greater than k, right? So I need to consider all the possibilities, right? That means the range of the elements which was having between low and high could also pair themselves up in each other so that the sum less than k, correct? So that means I need to do a L plus plus. So this would be my current L pointer, and this would be my current high pointer. Like I did not do any change in it, just L plus plus. So in that case, we will have a else, and we will say L plus plus. Now you can clearly see LNH is pointing to 5, which is which is not less than 5. So we'll again decrement our pointer this one, and you can see 2 and 2. Current sum is 4, which is less than 5. So this one is also one of our potential answer. That is 2 comma 2. And again, how do we get the count? It will just say high minus low, and high is pointing to 2, L is pointing to 1. So 2 minus 1 is 1, and you'll get the total count. So let's not waste further time, and I think you can pause this video here. Before starting the live code, you must try to code this as well yourself, because we have discussed each and everything for this question. Even I'm gonna pause the video and will not do the live coding because this is very self-explanatory now. Okay, let's do live coding. Okay, so what would be the stopping condition, like when your L and H meets, like H should not pass L, then that means that you have covered all the elements, right? So our while loop condition would be, while L is less than H, you're gonna operate something that is, uh, we're gonna declare a sum that int sum is equals to array of low plus array of high, and we have to declare the low and high pointers as well. So uh, array of let's say int low is equals to 0, and int h is equals to array of n minus 1, right? And we're gonna say int sum is equals to this one, and we're gonna check sum if sum is less than k, then in that case our answer would be answer plus equals to h minus l, high minus low. And if our sum is one second, one second. Yes, and if our answer is like, let's an else if condition, else if our sum is greater than our k, right, or greater than equals to k, in that case also we need to decrement our pointer, that is high minus minus, and there would be an else case, I would say low plus plus, right? And this should give you the answer since we have already declared the sum here. So let's just remove the int from here, and yep, I think this code will work. Let us compile and run. Okay, we did two mistakes. So this is the reason. I just wrote out the pair sum problem. Uh, uh, there would be two changes, I guess. So once we are comparing that if our sum is less than k, and then we are adjusting our answer here, also we need to do an L plus plus, right? Now we're gonna look for the elements which is in the range of L and H, right? So this condition will not be there, of course, and there would be an else if condition if it is less than equals to k. So what we can do is that we can also eliminate else if. We can just write else because there is only two case, so no need of else if. Okay, there were a couple of changes as well. Not the changes, we missed it. So sorting is necessary, and h is equals to n minus 1, not array of n minus 1. So I think it's the weekend vibe that I'm giving you to you guys. So yeah, now the expected and our output matches, and we can now hit the submit button. Again, what is the time and space? It will be O of n, as we are visiting each and every element just once, and rest of the operations are O of 1 operations. So O of n as space, O of n as time, and O of 1 as space. And we also should not neglect the time constraint regarding the sorting, because this is n log n, right? And this is the parallel work. So it is n log n plus n. In the worst, you can say it is n log n. That's it for this video. Till then, keep learning, keep going. Bye, and take care, guys. Uh, do watch out our next and playlist for all the DSA topics we have made. The lead code daily problem and lead code solutions, interview preparation, interview experience, and rest of the topics as well. Till then, bye bye.